So first chapter is a OS, operating system, and so let's start. What is a operating system? And my name is Sachin Sharma, and I am from NIT Warangal. So what is a OS? Okay, then OS is a operating system is a piece of software. It is a piece of software that manages all the resources of a computer system like hardware and software. Okay, and provide the environment in which the user can execute his or her program in a convenient and efficient manner by hiding and underlining the complexity of a hardware and act as a resource manager. Okay, so what it is this, what this definition is saying, OS is a software. Okay, OS is a software. It manages both software and hardware of a system. Okay, and it manages hardware and software of a system, and it provides the environment in which the programmer can execute its program in efficient manner. Okay, it's provide the environment. Okay, it's provide the environment where the user can execute his or her program without knowing the what is inside this, without knowing the complexity inside this environment, how it is working. Okay, so and what it is doing, another thing, it is managing the resources. Okay, hardwares. So what are the overall operating system is doing? Operating system is doing, it is handling the software and hardware of system, providing the environment and hiding the complexity for the user. Okay, and act as a resource manager. It is managing the different kind of resources, all kind of hardware and softwares. Okay, so again we read this. It is a piece of software. Operating system is a software. Okay, not a hardware. It manages both hardware and software and provide the environment where the user can execute its program in a convenient and efficient manner. Okay, without knowing the what is happening inside this. Okay, and act as a resource manager. So this is the operating system. So operating system is handling everything inside the system. Once the system is on, then everything is handled by operating system. Okay, so it handles the softwares, hardwares, memories, file system, and input IO, input output IOs. Okay, everything it will handle. Okay, so now see this. So what is the operating system? If let's see, if I am a user. Okay, I am a user Sachin, and I want some work. Okay, I want print some paper. Okay, then what is happening, I just click on a print option and it will print. So this is handled by the operating system. This is the whole system. This section is a operating system. It provide me a user space. Okay, where I can see the options and like browsing and VS code, etc. And kernel is working inside this, and we will see what is happening inside this. And it provide the output, a print, without knowing what is happening inside this. So this is the operating system. Okay, and so what are the functions of a operating system? Let's see. It's manage the resources, provide the interfaces, and manages the memory, and isolation and protection of a memory. Means what? This means what? If I have a memory segment this, and one process is uh, TikTok is there. Okay, TikTok is there and Insta is there. Okay, so if I running both a system and music player. Okay, music player, so I am running three programs. Okay, three programs. So what is happening? So this is the my memory, my system memory. Okay, and let's see this. Okay, so this is the music. This memory is taken by the music. Okay, and this memory is taken by TikTok, and this memory is taken by Instagram. Okay, this is my RAM memory. Okay, now operating system is managing, providing the isolation this part of a memory to this part. It is not intermixing this and handling the this memory efficiently. Okay, in a parallel manner, because the music is also running, TikTok is also running, Instagram is also running. So it provides the isolation of a memory and protection of a memory. So these are the main function of our operating system. So so see this, what are the types of a operating system. Okay, so let's understand first point. First point is what? First point is what? Note that one CPU can run one process at a time. Okay, or one job at a time. Okay, it will run one thing at a time. A process having a several uh, jobs, job 1, job 2, so it will happen, it will running only one job, okay, at a time. So note that first, an old version of operating system is a single process operating system. Okay, where there is only one, there is only uh, one CPU. Okay, one CPU. Okay, and what is happening if there is a several jobs? Okay, if there is a several jobs like process 1, process 2, process 3, okay, process 4, these are the jobs. And what is happening when the one process is scheduled to this, until and unless the first process P1 is completed, then and P2 is not going to enter into this CPU. Okay, if let's see what I am going to explain you. If this is the CPU, okay, and if P1 is entering, okay, and now P1 is need a IO, some input output operations, then it will goes out to perform this IO. Now this process is here. Okay, now CPU is empty, but P1 P2 can't utilize this CPU because it is occupied, occupied by the P1, but P1 is not there, P1 is IO. So this is the disadvantage of a single process. Until and unless whole P1 is completed its all operation, then then the P2 will be scheduled to the CPU. Okay, now if P1 is completed, then P2 will be scheduled. Okay, so disadvantage of this is, if CPU is empty, CPU is empty, and P1 is using IO. Okay, and CPU is empty, so P2 can't enter or can't utilize this empty CPU. Okay, until and unless P1 is completely fulfill its operations of IO or something, CPU as everything is completed, then P1 P2 will be the going to enter into the CPU. Okay, so utilization is very poor. So okay, example of this CPU, this operating system is a MS DOS. Okay, MS DOS. Now next is a batch processing operating system. It is better than the single processing. So what is happening in this? Let's say there is a several job J1, J2, J3, J4. There are the several jobs. Okay, so it will what is happening in this system, operating system, it will combine the similar kind of jobs, similar kind of jobs. Okay, like J1 and J2 is similar, so it make it a batch one. Okay, and J3, J4, J5 is a similar kind, so it will put a J3, J4, J5 etc in a batch 2. Okay, then it will run one by one, batch wise. Okay, let's say first batch is running like a single process. Okay, it will run batch as a single process. First J1 is completed all the processes, then J2 will be scheduled. Okay, so if batch 2 is running in a CPU, so first J3 is completed all the IO operation, CPU operation, then J2 will be the enter into the CPU. Okay, so this is also indirectly a single process operating system, but different is it is making the batches. So this is the second kind of a operating system. Okay, the example of a this is a Atlas. Okay, Atlas. So each batch is behave like a single process operating system, and utilize is not improved. Okay, so utilize in this also not improved. So third is a multi-programming operating system. It is better than the previous one, and let's see what is happening in this. So there will be a single CPU. Okay, single CPU here. Okay, and multiple programs can run. How the multi-program operating system work? Let's see. There will be the ready queue. Let's say this is the ready queue. So here the CPU concept, single CPU is there. Ready queue concept is new. Okay, ready queue concept is new. Let's say if there is a several job J1, J5, J2, J4, etc. Okay, and this is the CPU. If J1 is going to J1 is going in a CPU. Okay, utilize the CPU. Okay, then let's say between the CPU execution it need a IO operations. Okay, input output out operation. Then J2 will going to J1 is going to take a IO operations. Then now this time the CPU is empty here. Okay, CPU is empty here. Now to utilize this time, we can switch. We can uh, upload, or we can J2 will J5 can utilize this CPU time. Okay, J5 can utilize the CPU time because J1 is not there in a CPU and J1 is busy in a IO operations. So context switching is happening. Okay, so context switching is what? So J1 is first in CPU. It is now it is going to IO. So the current context of a J1 is saved in a PCB. Okay, and current context of a J2 will be J5 will be the restored. So context switching in this operating system, they introduce the context switching. Okay, so it utilizing the CPU in a better manner. So utilization of a CPU is better. Utilization of CPU is better in this. That's why it is called a multi-program, because we can run multiple program at a time. Okay, so this is the advantage of this. So new thing is what? Context switching introduced in this operating system. So next, operating system of multitasking. It is a much better version than old one. Let's see what is happening. There are also a single CPU. Okay, single CPU, and context switching is already there. Okay, context switching is already there, and it is slightly better than the multi-programming operating system, because it is slightly better than the multi-programming operating system, better than this operating system, because it introduced the time sharing. Time sharing is there. Okay, this is the extra feature in this time sharing. Let's say these are the jobs J1, J2, J3, J4, etc. Okay, now CPU is there. So if we fix a time quantum is a what is the time the J1, J2 these processes or jobs used in a CPU. This is the time quantum. Okay, time quantum. Let's say this is the 2 nanosecond. Okay, if J1 is going to utilize the CPU, and for us 2 nanosecond, then it completed 2 nanosecond, it come back to this, and this will going to use this. Then 2 nanosecond is completed, and this is going to utilize. Like that, they are sharing the CPU time in a time sharing manner. Okay, so all the processes is running and utilizing the CPU in a efficient manner. Okay, so it is better than the old one, multi-programming operating system. Example of this is the round robin. Okay, you here the this round robin is based on the time quantum. We will study what is a round robin in a CPU scheduling chapter. Okay, and performance is very increased. Okay, performance is improved performance is improved highly. Okay, so example of this is a CTSS. Okay, this is a operating system which is based on the multitasking. So you understand, multitasking means uh, it introduces the time sharing manner. Okay, like time quantum. Next operating system is a next operating system is a let's see, multi process operating system. Okay, multi process operating system. So what is happening in this, there are the multiple CPUs, not a single CPU. Okay, let's understand this. Multi CPUs are there. Okay, this is the latest. Multi CPUs are there, and time sharing also there. Time sharing is also there. Context switching is also there. Okay, context switching is also there. So let's say if there are the multiple CPUs are there, CPU1, CPU1, CPU2, CPU3, CPU4, etc. CPU4, and there are the multiple jobs. Okay, J1, J2, J3, J4, etc. So we can run parallelly many jobs. Okay, so automatically the performance is very high in this. Okay, you hear na octa core process. So it means that there are the um, there are the eight multiple cores. Okay, CPU cores. So 8 operation can perform at a time. So 8 CPUs are there. Okay, so these are the example of octa core. Okay, quad core, etc. Quad core means 4. So these are the modern technology. They are the 4 operation can run at a time. So multiprocess is extra in this operating system is a multiple CPU. So automatically uh, performance is increased. Example is a window. Okay, Windows. Our modern systems are okay, iOS. So these are the example of a multiprocessor. So next operating system is a what, distributed operating system. Okay, distributed operating system. It means it means there are the distribution of a work. Okay, these are the OS, and it distributed its work. Okay, it distributed the work in a several models. Okay, like CPU memory is there, CPU memory. Okay, and this is another CPU memory. So here and here, these are the CPUs. Okay, so it distributed the some work to this, like P7, P1 jobs to this, process to this, and several process to this, several process to this, several. So their operating system is distributed. Okay, their work. So example of this system is a locus. Okay, now next operating system is a real-time operating system. Okay, In real time operating system is used for real time purposes like bank, okay, bank, etc. So where we need a, okay, where we need a time related things, okay, accurate thing and the real time thing like a banking systems, etc. So time constraint things use the real time operating systems, okay. So in this, what is the feature? Real time, it works on a real time, and fast execution. Fast execution is there, okay. Like airlines use this, banking use this, nuclear plant use this operating system, okay. These are the example, and example of this is ATCS, okay. This is the operating system which use this real time operating system. So again I am going to give you a brief what we studied in this, okay. So operating system is a software that manages the everything: hardware, software, resource manager, and memory management, provide the interface and etc. And single process where the one job is completely completed, then second job is going to um, schedule in a CPU. And batch, similar kind of job makes a batches, then batch by batch it's performing the uh, operation like a single process operating system. And third is the multi-programming where the context switching is introduced. Then next is a multitasking where the time sharing is introduced. Then fifth one is a multiprocessing where the multiple CPUs, the octa core, quad core, etc. is introduced, okay. And then the distributed operating system where the distribution of a work is there, okay. It is also called loosely coupled because they are the several models which are combined to work together. And real time is used for banking system, airlines, and nuclear plants, and it works on a real time. It is very fast and accurate. So where we need a time constraint thing, then we will use the real time operating system. So thank you. And last topic is goal of operating system. So goal of operating system is a primary goal is a convenience, and second goal is a efficiency, okay. So these are the goal of a operating system. So understand what is a convenience. So it is convenient to user and efficient to user also, okay. So these are the goals of a operating system. Thank you.